Hello, this is a video for COMP345, Advanced Program Design with C++. This is for the fall 2021. Here I'm going to be presenting the project description. Now, there's a few things to be talked about for the project. First of all, you need to form teams. So if we go to the Moodle, then there are things. I don't have it here. Okay, let me go then to here. So team lists are due by September 17th. This is my web page. So I'm going to add this to the Moodle, of course. So you have to form teams by September 17th. These teams need to be teams of exactly 5 students. I'm not accepting other number of students than 5 for a team. If you can't have a team of 5, then you may form teams of less than 5, and then I'm gonna somehow on September 17, if the teams are not of 5, then I'm gonna merge teams together to have teams of 5. So by September 17, whether or not you have a team or whether or not you have a team of 5, I'm going to make all the teams that I have actually teams of 5. If you do nothing about forming a team and you're an individual that is not assigned a team, I'm going to put you inside of an existing team. So there's not going to be anybody that is not in a team of 5 by September 17th. Well, there might be, because it might be that the number of students is not divisible by 5. If that's the case, then I'm going to decide which teams are going to be, in this case, teams of 6. But you're not allowed to form a team of 6. Only I am allowed to form a team that is not a team of 5. So how do you form teams? So if you go to the Moodle, you will see group self-selection here. So if you click there, then you should be able to edit some of the teams that exist there and actually add yourself into a team. So please, before you do that, contact the students that are in the team, which are going to be listed here as people who have created the team. Contact the people in the team before you add yourself in the team, and make sure that you all agree as to for you to be in their team. Much better is that you actually discuss with people before you actually form a team. There's some discussions to be had as to, what are your habits, what IDE are you using. For example, some people might use Windows, some other people might use a Mac. So if you want to work together, it will create additional problems when you want to merge your code together. You might think, well, it's all C++, so it should work. There's always some problems related to that. So it's better, I would say, if everybody in the team agrees as to what compiler or IDE that you are using to do the development. Also, I strongly suggest that you use versioning repositories such as GitHub, for example, or Bitbucket. So you should all agree as to what is it that you're going to use if you are using a versioning repository. So all this to say, much better if you discuss with people before forming teams. Eventually, well, if you don't form a team of 5, let's say you come at September 17, you're only 3 in your team, then what's going to happen is that I will go over the list of all the teams and the people that are unassigned, and then I am going to merge teams together. And then these are going to be people that you don't know, okay? So I advise that you actually try to form your own team by yourself so that you at least know the people, at least you discuss with people before forming a team. My experience is that the teams that that were formed by themselves perform better in the project. Not to say that some teams, that invariably all teams that I formed do not perform well, but on average, a team that has made a decision by themselves to be together is generally functioning better. So forming a team of 5, exactly 5, by September 17th is your first assignment, okay, your first duty. Again, if you don't have a team of 5 by September 17th, I will form teams of 5 on this particular date, and then project is going to start. Other thing is, as I said in the introductory video also, invariably there is some teams that have some problems. I guess you all have heard about teamwork not turn out to be very good due to lots of reasons. Some students sometimes are not very cooperative. Important to realize that in this course, you will all receive the same grade. Everybody in the team will receive the same grade for an assignment. There's not going to be different grades depending on who did what or did not do what in the current assignment and in the project. It's up to you to organize your communication well, to work in advance throughout and throughout the semester, and make sure invariably the most frequent source of problems is, of course, people delay starting of the work, a few days before the due date of an assignment. These assignments are not, toy assignments. They require a lot of thought, and they require a lot of time to do the programming. Especially if you are working, if there are different people doing different things in the project, you might assign different tasks to different people. Invariably, as you may know, when you will try to put this code together, invariably it will not work. So integration is one of the key issues when you have different people working together as a group to do some software development. So you have to reserve some time to actually do the integration, at least. Okay. Even if you start early, you have to dedicate some time for the integration. Best thing is to use a versioning repository, and that, periodically you actually compile the code that is submitted, and that possibly somebody is responsible to make sure that everything works well, and that the development is, everybody is committing code as often as regularly as they are developing code. Worst thing is that somebody is working on their own, and everybody is working on their own, and then the day before the deadline, then everybody commits once, and then you hope it's going to work, but no, it's not going to work. It's never going to work if that's how you think it's going to work. So start early, use a repository, make sure that everybody is on the same page, and have a way to make sure that you communicate regularly to make sure that you will not run out of time for a particular assignment. If things are going not so well in your team, some people are not responding, at the first occurrence of somebody not responding, please send me an email, and then I'll try to fix the problem. Okay, this is not about you snitching on somebody. This is making sure that your team is going well. Okay, if you wait, the more you wait, the more it's going to become more of a problem. So if you don't hear about somebody, there might be a reason. Maybe this person dropped the course. If the person dropped the course, then whatever you have assigned to this person must be done by the other team members. Okay. Maybe this person is busy on something else. Maybe this person is sick. Whatever is the reason, if you don't hear from somebody after some time, please communicate with me, and then I will try to investigate and see what's the problem and try to get the person on board with the project. Okay, so very important. If something is not going well in your team, please contact me and I will try gently to fix the problem. Okay, so here you see, here's a link to the project description handout. So if you click here, this is going to be bringing you to a link to my web page. So if you click here, then it's going to bring you to this project description here. Okay. Another thing is that you will see, and I will tell you this right away, that this is the same topic as I've given last fall. Now, it's the only intersection between this project now and the project from last year is that it's the same topic. You will see that this document here looks like it's the same project. However, when you will receive the assignments, there will be some differences that make it so that it's not going to be the same solution. Okay, so if you are tempted, if you figure this out now and you might know somebody from last year and you say, oh, maybe I'm going to reuse their code, I'm going to make it so that it's not going to be a joyride for you just reusing other people's code and then everything's going to be fine. No, I'm going to make it so that there's going to be key differences that are going to make it so that it's not going to be the same project, even though it's the same topic and it's somehow doing the same. It's going to have to be organized in a different way. Okay. So getting somebody else's code from a past year is probably not a good investment of your time. There's going to be so many differences that it's going to be probably more trouble trying to reuse the code and change it rather than do the code yourself from scratch. Okay. So I would advise just start from scratch. It's not that difficult anyway. It's a sizable project. It's not extremely difficult and very long project. Okay, so there will be 3 assignments. So these project, essentially I designed this project so that it's an entire project that is divided in 3 different builds. For those of you who know incremental development, so basically your assignment 1 is going to be the first version of some of the requirements of the project. And then in build number 2 is going to ask you to do more that is going to require that you integrate all the parts of assignment number 1 together and then make it do more features, implement more features of, in this case, the game. And then in build number 3 or assignment number 3, it's going to add even more requirements and then ask you to do the whole thing. Okay. So it's essentially a project that is divided in 3 assignments in the style of incremental development. So 3 assignments. The due dates are already posted on the Moodle and on my website. So please look upon that. For now, the first assignment is not given to you for now. Your duty for now is to form a team and be, as I mentioned before, it's important that you try to form a team with people that you know it's going to work well, especially that you'll be using the same tools and everybody agrees we're going in the same direction. Okay. And then that you, so after your team is formed, then that you actually make some research about, because this is a game, there is some rules of this game. I provide here an example of the game. Maybe you can get together and play this game and understand how it works before I will give you the first assignment. Okay. So that's what you have to do before you receive the first assignment. So problem statement. So essentially, this is an implementation of a computer game named Risk. So for those of you who know Risk, it's a board game quite an old board game. The idea being that in the original game Risk, you have a map of the world that is divided into countries and continents. And then there are players that eventually come to own somehow some of the of the countries at the beginning of the game. And then they also are given some armies that they actually are putting on some of their countries. And then the game starts after this, and then the objective is, well, to attack. A player would attack neighboring countries and conquer neighboring countries. And then the objective of the game is for one player to actually control the entire map and thus win the game. Okay, so it's a world conquering game. The original Risk game, I already had some projects using this game, but this one is considerably different from the original Risk game. So if you know Risk, this is not exactly what I'm asking for here. What I'm asking for here is what is called Warzone. So I invite you to click here and go to this. It's an online version of this game. You don't have to pay or anything. It's an online game that you can play in your browser. Okay, so I invite you to actually play the game and familiarize yourself with how it works. Okay, very important to understand that I'm not expecting that you make like a copy of the Warzone game that you can play in a browser. Absolutely not. Okay, so what I'm expecting is that eventually you're going to have some implementation, for example, that implements a map of this game, and that you implement some players, and then eventually that the players are given some of the countries in the map, and then eventually the players can put some armies on the map, and eventually you can have some orders that are given by the players that eventually gonna make the players conquer some other countries, eventually being able to control the entire map. Okay, but nowhere will I ask, for example, for a GUI to be implemented or anything like that. Okay, so yes, the Warzone, that link here that I'm giving you is just an example of a full-fledged game implementing a full-fledged software system that implements this game. I'm not expecting that you will have a GUI, for example. Okay, that would be way too much asked for, and it goes way beyond the scope of this course. Essentially, what you'll have to do is to implement some kind of skeleton of this game that you will play on command line. Okay, so it's going to have some of the, I'd say the game engine of a Warzone game, and you're going to be able to somehow play this game, but you're not going to see it take effect as in this particular Warzone game on the internet. It's going to be very clear what I'm expecting from you starting at assignment number 1. Okay, I'm going to be very, very specific as to what is it that I'm asking from you. So here, this project statement here is just an introduction to give you some idea of what is involved. Okay. Very important to understand also that I'm not claiming that this, for example, this problem statement here or this project description here is giving you the answer to all the questions. That's part of what is software development. When you get a contract to develop some software, you get some meetings with some clients or with your boss, and then you are told, well, I want to have a software solution to solve problem X, which is characterized as features A, B, C, D, and F. And then that's how you're presented. That's how it is presented to you in the beginning. Then as a software developer, it's up to you to figure out, well, okay, when you say feature A, for example, software must be able to do X. And invariably there are some questions. What do you mean by that? What does that imply? What is it that you want exactly? What is it that maybe you don't want? What's the scope of every of these things that you are stating? Okay. So you should see this project description here as the initial description of the project that you are given. It is not answering all of these questions. It's not even pointing at all the questions that need to be asked in order to solve this problem. It's just a very vague, appears to be very precise description, but invariably, as you will read this, there's going to be a lot of questions to be answered as to what exactly do I mean by that? What exactly do you have to do? Okay, so I'm doing this, I'm making it apparently very precise, but invariably there's going to be missing information. This is done on purpose to make it like a real life experience of software development. So essentially, so you have a map, you have players. The map is composed of countries, and then the countries are connected together. And then the players own some of the countries, and then there are armies on each of the countries, and then the armies are moved to other countries to try to conquer other countries. The objective is that one player actually controls the whole map, and that's how the game is won. So what is the map? So that's a very general description of what this game is. So what is the map? What exactly, apparently exactly, what is this? What is the concept of a map? The game map is connected graph where each node represents a territory owned by one of the players. So what's important here, as soon as you read this, is for you to identify what are the keywords, which are going to tell you what are some classes that you're going to have to implement. Okay. There's also some technical terms that I'm using, which are very important. For example, the map is a connected graph. So I'm assuming here as a computer scientist, you know what is the notion of a connected graph. Okay. And you should, if it's not that clear for you, then you should make some research as to what is a connected graph. Where each node, again, a graph is composed of nodes, and then the nodes in this graph. So, for example, I have one graph, such graph here. I'm going to come back to this later. Okay, so I have a graph here, and here are some nodes, and here are some edges between the nodes, and then eventually it forms an entire graph. Okay, it is also a connected graph. If you make your research, you will figure out that meaning of connected graph is that from any node that you select in the graph, if it is a connected graph, then you should be able to move or to connect to any of the other nodes independently on from which node you start from. So there should not be parts of the graph that are not connected, that are disjoint from each other. Okay. So this notion of connected graph is going to become a central issue in your design, of course. So it's a connected graph. Each node represents a territory or country owned by one of the players. Okay. So the nodes are countries and they are owned by players. The edges between the node represent adjacency between territories. For example, if you are in this territory here, let me stop the sharing here. So if you're in this territory here, then let's take this one. If you are in this territory here, then the only place you can go to is to this other territory here. If you are in this territory here, then you can go to this one here or this one here. So you see that some of the edges are unidirectional. Okay, so if you're in 7, you can go to 8, but if you're in 8, you cannot go to 7. Well, unless you actually go through 6 and then back to 7. Okay. So you see that there some of the links are unidirectional, some of the links are bidirectional. Okay. This, of course, has a lot to do with the notion of connected graph also. For example, here in the middle here, you have a hub of some kind by which if you want to go from, because here I have identified the blue, this is a continent. Eventually we'll see that. This is these 3 countries or territory formed, like, for example, the blue continent, which is a group of territories. You have the red continent here, the purple continent here, and the green continent here. So you see that this red territory here is some kind of hub by which, for example, if you control this continent here and you want to control this here, you have to go through this territory 13 here, even though it belongs to this red continent. Okay. So this is here a connected graph. It is composed of nodes which represents territories, and then the adjacency between territories represents the fact that you can move armies from one territory to another. For example, if you have armies here, you can move them from here to here, but you cannot move from here to here. Okay. You can move, let's say, for example, you own this country and you own this country, then you can move your own armies from one of your country to another of your country, not a problem. But let's say, for example, this does not belong to you and you move armies from here to here, then that would mean you want to attack this neighboring territory, okay, in order, of course, to possibly conquer it. Let's go back to the description. So edges between nodes represents adjacency between territories. The map is divided into subgraphs that represent continents. So that's what I meant here, but this is the blue continent, this is the red continent, this is the purple continent, and this is the green continent. Okay. A continent is a connected subgraph of the map graph. So we'll come back to that later. So what does that mean, a connected subgraph? A connected subgraph of a connected graph is a subgraph, meaning you extract this subgraph from the main graph. If it's a connected subgraph, it means that this subgraph that you extract itself, in isolation from the other part of the map, is itself a connected graph. Okay. So for example, if I'm just giving you here like random discussions about what does it mean, so that to give you some insight about what kind of questions you might ask yourself. Because again, I repeat, this seems to all make sense and be a complete description of what you need to know, but there are some hidden questions in this description. So for example, if you see here this continent, blue continent here, if you extract it from the entire graph, then basically that means all of this here does not exist anymore. So you see that if you're in 1, you can go to 3, 3 you can go to 2, 2 you can go to 1. So this is essentially a connected subgraph. If you take the red one and you extract everything and you keep only the red, then you can move from 4 to 5 to 13 to 4. And this is a connected subgraph. Same thing with the purple. If you're in 6, you can go to 8, you can go to 7. If you're in 7, you can go to 8, you can go to 6, and then 7. So each of them is reachable to any of the other ones. However, if you take the green continent and then you extract it from the graph, means these links are not there anymore, then if you are in 9, then you can go to 10, 12, and 11. But if you are in 10, you can only go from 10 to 12 to 11, and you can never reach 9 here. That means the the green continent is not a connected subgraph. So for that reason, this map here is an invalid map, okay, according to my definition, because it violates the restriction that every continent must be a connected subgraph, because the green continent is not a connected graph. However, if you keep the green continent inside of the entire graph itself is a connected graph. For example, if I'm in 9, remember, if I was in 10, I could not go to 9. But if this continent is connected to the rest of the graph, then if I'm in 10, I can go to 12, 11, 13, and then 9. So if this subgraph is connected with the rest of the graph, then it's still a connected subgraph, because it can actually use other nodes to actually be itself a connected graph. But if you extract it by itself, is not a connected subgraph. So you see, this is an interesting, also theoretical problem. Okay. Each continent is given a control value, a bonus in war zone territory that determines the number of armies per turn that is given to a player that controls all of it. So there's going to be players, and then players are going to own some of these countries. Okay. And then each player, the way the game is going to work is that each player is going to be given a turn. And the first thing is going to happen in the turn of a player is that they're going to be given a number of armies. Part of this number is going to be whether or not they control a certain continent. So for example, continent blue might be worth, for example, 5 armies. If you control all the blue continent's territories, then at the beginning of your turn, you're given a bonus of 5 armies. Okay. That's the only reason why continents are important in the game. They give you bonus armies if you control all the territories that belong to a continent. During gameplay, every territory belongs to one and only one player and contains one or more armies that belong to the player owning that territory. So as soon as a certain player will control a territory, then they will be allowed to put some armies on the territory. Okay. If you read carefully what I just said, again, every territory should belong to one and only one player. You cannot have a territory that does not belong to any player, and you cannot have a territory that belongs to more than one player. One and only one player owns a territory. In your implementation, will be expected that the game can be played on any connected graph that is defined by the user before play, saved as a text file representation, and loaded by the game during play. So when you start the game, your game will actually read a map that is stored in a file, in a text file that stores the information about the graph that composes a map. And then the software will read this file and then somehow create this connected graph data structure that represents, operationally speaking, this map at runtime. Okay. So your game should be able to read any of these files that can represent any kind of graph. Okay. So your game will not only run on one specific map, it will be able to run on any map that has been saved as one such text file. So then, this is about the map. Okay.
So you see that I've discussed some of the things here. You probably see, you probably already have, some of you probably already have a list of questions about things that I said that were not that clear. That's your first duty in this project. Read this and then try to figure out what is it that I don't say in this document. Okay. Again, this is what happens in real life when you develop software. Client might tell you, oh, here's what I want. And the client might say, oh, but this is very clear, so on and so forth. But then your first duty is to first inform this client, well, that's not that clear. Here's my list of questions, which some of these questions might be very puzzling to your client or your boss. That's first thing first. When you develop software, figure out what is not clear that enables you to clearly implement the right thing that solves the right problem. So the game starts by the startup phase, where the number of players is determined and all the territories are randomly assigned to the players. So first, you load this map, there's territories and so on, and first you determine who are the players, how many players are there. So for example, you determine 3 players, name player 1, player 2, player 3. Then you need to assign some of these territories to the players. You need to figure out a way to assign all the territories to all the players. And then these players own these territories. First thing first. Then the turn-based main play phase begins, in which all the players are creating a set of battle orders. Okay, so there's a terminology here of the game. So the players will make some decisions as to, for example, they want to attack from 1 to 2, move some armies from 1 to 2, which results in an attack. So these are orders that the players are creating that are going to result in some actions that are going to be taken later on by the game. After all the orders have been given for all players of a turn, in a turn, they are executed by the game engine. So there are 2 different sub-phases. First of all the players will specify what are their orders for this turn. This does not mean that these orders are executed. You just get the list of orders that the players wish to execute in this current turn. Then each of the players give their orders. They are not executed yet. And once all the players agree, we don't have any more orders for this turn, then the game engine takes this list of orders and then executes them. Okay. So when you issue an order as a player, it's not executed right away. Okay. It's a very different mechanics compared to the original Risk game, for those of you who might know this game. The orders are first, deployment orders, advanced orders, special orders resulting from using cards. So here you have this notion of cards. Again, if you know the Risk game, you might think you know what are the cards. That's not the same cards. Okay. Don't make assumptions. Very, very common. Software developers will make assumptions to assume that when they are told something, their client or their boss is telling them something, to assume that they know what they're talking about, which leads to, of course, a lot of problems later on, because you might be making a wrong assumption, then you implement something based on a wrong assumption, then you basically did this work for nothing. So it's important that you read this, and everywhere you assume something, then you should ask me during class. Is it exactly, to ask me, what do I mean by that exactly? Okay. For every lecture time that we're going to have, being on Zoom or in person, I'm going to reserve some time at the end of the lecture time to, I'm going to open the floor for some questions for the project. I'm going to assume that you have, some students will have a list of questions to ask me, okay? If there's no questions, I'm gonna myself be making some discussions such as making now, but invariably I'm not gonna answer all the questions. So it's your duty to come up with some questions at every lecture time so that I can discuss answer to your questions. So what are these special orders? So there's the deploy order, advance order, bomb order, blockade order, airlift order, negotiate order. So these are all orders that you can create, that a player can use only if they have the card that corresponds to this particular kind of order. Here, I'm not gonna go explain all of this here. What's the meaning of these orders, because I want this video not to be too long, and we're gonna leave this for discussion points when we do the lectures. Okay, so as you issue orders during your turn, you can either issue a deployment order or an advance order, or if you have some cards in hand, any of those cards here, then you can play the card and then issue the order that corresponds to it. These are deployment, advance, and all of these here are the only orders you can issue during your turn as a player. And this is the issuing orders phase. So each player in a round robin turn order give one of their orders. Let's say there are three players. Player one gives one order. Player two gives one order. Player three gives one order. This goes back to player one. 1, 2, 3, 1, 2, 3, 1, 2, 3. And this whole thing, for this turn, the issuing orders phase stops when none of the players have a new order to create. Okay. So that signifies that the issuing orders phase is done for this turn. Okay, so that's the objective of this phase, to issue orders. Another thing that happens during this phase is that at the beginning of the turn, you're giving every player is given a number of armies. So, for example, in your turn, you're given, for example, 10 armies. Then some of the orders you can do is called deployment orders, by which you say, I want to put, say, 3 armies on my territory 1, 3 armies on my territory 2, and 4 armies on my territory 10. Okay. So these are deployment orders. This is where you take your armies you were given for this turn and you deploy them on some of your countries or territories. So what is this number that you get? So there are 2 things. So the game engine will compute how many territories you have, and then we'll divide it by 3, and then that's going to be the number of armies that you get. But this number should be minimum 3. So if, for example, if you control only one country, 1 divided by 3 is 0, but minimum is 3, so you're given 3 armies. So number of territories you control divided by 3, but minimum 3, rounded down. If a player owns all the territory of an entire continent, then the player is given the number of army corresponding to the continent control bonus value of this continent, which is defined in the file defining this map. We'll see much later what is, or when we define assignment number 1, what is the contents of or the format of these files, the input files. Okay, so I'm not going to read everything here. So this is for the advance orders, where you're given armies, and then you can, the deployment orders. This is where you receive armies, you put the armies during your turn using deployment orders. Another kind of order is advance orders. Advance is you take some of the armies that you control on one of your territories, and then you move them, you advance them to a neighboring country. So this is where these adjacencies here are important. So for example, if you control this territory here, you can advance armies from here to here or from here to here. You cannot advance from here to here because there's no edge between these two nodes in the graph. Okay. So you're allowed to move any of your armies in any of your territory to one of the neighboring territories of the territory you chose. So these are the advance orders. If you're advancing armies from your territory to another of your territories, eventually that's going to move these armies here. If the territory that you want to advance to is an enemy territory, then it's going to result in a battle. Okay, so once all the orders have been issued by a player, they signify so to the game engine. So keep in mind here, this whole phase here is issuing orders. When I, for example, when I say I want to advance from here to have an attack, for example, the attack does not happen now. I just basically signify to the game engine that eventually you want to attack from here to here. The effect of this attack is only going to be executed at the next phase, which is the executing orders phase. Okay. Okay, once all the players have signified that they are finished issuing orders, the orders are executed. So you go to the executing orders phase. And then once you go there, no other orders can be created or issued. Then in the issuing order phase, essentially the game engine will look at the list of orders issued by every player. For example, player 1, first order, will get the order, then execute this order. Then go to player 2, order number 1, take this order, execute this order. Player 3, take the first order, execute the order. Okay. Then goes back to player 1, and then like this until no orders are present in any of the players' list of orders. Okay. So here, there's also attacks. I will leave the description of what is attacks for questions during for the question times during the lectures. Okay, so please have a look at how it's described here. And you will quickly see that it appears to be clear what it is, but eventually you're going to figure out that it's not that clear. Okay. The idea is that if you have an advanced order, let's say you have 10 armies here, there's 1 army here of a defending player, you move these 10 here and you have a battle between 10 and 1 army, very likely that these 10 armies will kill this 1 army. If that happens when there are 0 armies and as a result of an advanced order, then this territory has now been conquered by the player that gave this order. Okay. And that's how you eventually win the game, by conquering all the territories in the map. And then also, here this is describing what is the effect of the orders that results from playing a card. For example, if you use a bomb order, so when you use a bomb order, you target a certain territory, which results, if the bomb gets correctly executed, it results in this territory to lose half of the number of armies that reside on this territory. So that's just one of the examples. Again, I'm not going to describe them all here. Then eventually, there's going to be some territories that are conquered by a certain player. then eventually it will happen that a certain player does not own any territory on the map anymore, in which case this player should be removed from the game. So there's now one less player in the game, and the game ends when there's only one player left in the game. That, of course, controls all the territories on the map, and then this player is said to have won the game. Okay. Now that's the end of this presentation. It's been quite a long description, but I remind you that maybe you think this is very clear, but there is so many things that I did not say. For example, I did not describe what's the meaning of these orders here. What's their effect when you execute them? There's a lot of things I did not say here. Okay, so it's up to you to come up with a list of questions during class time, either on Zoom or in-person classes, and then come up with your questions, and then I'm going to give you the answer to the questions and have some discussions so that everybody can benefit from the questions you ask. Okay. I can also answer your questions by email, or if you want to come to my office hours, of course, I'm going to answer the questions there also. But it's much more beneficial if you ask your questions during class time, and then everybody can benefit from, the questions asked by other people. Okay. So that's it for this today. So see you in class. Bye-bye.